Okay, Assalamualaikum everyone. I will start with this tutorial for the root locus procedure on how we can sketch a root locus following the procedures that we have learned. So before this, in 3.3 root locus procedure, we have learned when we want to sketch a root locus, we can follow the rules, which is we have 10 rules that we can follow. But basically for that rules, it was as a guideline only, so that basically not necessarily we will have to follow all of those 10 rules. So we have 1, 2, 3, so and so on until 10 rules. But basically when we sketch a root locus for any question given to us, uh, it depends. It is depends on the question. So not all of the rules that we should follow, but basically based on this question, so I'm going to show you on how to draw the root locus for this particular system, which is we have a Y-shaped automatic steering control system given as this closed loop feedback control system, which is a negative feedback control system here. And we have this system, so that I have rewrite the system here. So to begin with this question, let me check what are the rules that we can follow. Okay, first thing first, what we normally do is if we are given the sort of transfer function, what we do is to find its poles and zeros. Okay, so for the rule number 1, it is just a guideline. When we sketch the poles and zeros, we can just mark it as cross for the poles and the round shape here as a 0. Okay, so rule number 1, just skip. Okay, we already know that. Okay, how about rule number 2? The number of numerator's roots indicates the number of zeros. The number of denominator roots indicate the number of poles. So basically for the rule number 2, we will need to find the numerator's root and also denominator's root. Okay, so we will start with rule number 2. Rule 2, to find the numerator roots and also denominator roots. So we'll start with numerator roots. We have been given the numerator equation of k s plus 2 and s plus 3. To find the root, make this equation equals to 0. Then basically we will have the roots for this numerator equation as s equals to -2 and -3. So basically these roots we call it as zeros. So how many zeros we have here? So basically we have 2 zeros. Okay, these 2 zeros located on a real axis of the S-plane. Then we find the denominator roots. Okay, so the denominator equation is s plus 4 and s squared plus 2s plus 2. So force this equation to 0 so that we can find its roots. So here the roots for denominator are s equals to 0, -4, and for s squared plus 2s plus 2, you can just use the formula. You have learned it in the calculus to find the roots for this sort of quadratic equation using -b plus minus square root of b square minus 4ac, right? Okay, so using that, you will get the roots, which is in terms of complex conjugate. we have two complex roots, which is -1 plus j and -1 minus j. So we have how many poles? So the roots for denominator equation or characteristic equation, this is actually the characteristic equation. Characteristic equation. So we have how many roots? We have 4 roots, which is we have 4 poles in this case. Okay, 4 poles. All right. So once we get poles and zeros, we can proceed to another rule. I'm going to use this. Do it like this. Okay. We can check to another rule, which is rule 3. Okay. Rule 3 states that number of branches is equal to the number of upper loop poles. So we have 4 poles. So that meaning that we have 4 branches, 4 lines of locus. Okay. But when we have a combination of poles and zeros, basically, let's say for this particular system, we should have 2 poles that end up to 2 zeros. Okay, let's say we have that pole and the other pole. So basically for the first branch, that is the first branch, and the other branch. Let's say, how about for the complex conjugate poles? Complex root poles. Let's say that is the complex number poles plus imaginary axis, negative imaginary axis. So how about these 2 poles? So basically these 2 poles will end up to the infinity. So based on the rule number 3 here, so we know that we have 4 branches with 2 branch and will end at 0. Okay, start from pole, end at 0. There's 2 branch. So the number of locals that will end at infinity, be infinity, we can use the formula. How many locals will end at infinity? So B infinity equals to summation of number of poles minus zeros. So we have number of poles, which is 4 poles, minus number of zeros 2. And we know that 2 locus will end at infinity. Meaning that we should start from 2 poles here, the complex roots here, and then it will end at infinity. That is the thing that we are going to remark based on the rule number 3. So far we don't have a problem for the real axis locus. Okay, for the real axis locus we don't have a problem. Okay, now we are going to follow rule number 4. So the branch that will end at infinity or will move toward infinity are based on the following asymptotes, which is straight lines, angles. Okay, so we need to find the asymptotes angle for the poles that will end at infinity. So we know that 2 locus or 2 branch will end at infinity start from complex root poles. All right. Okay, start from -1 plus j and from -1 minus j. This locus start from here and will end at infinity. These two locus, these 2 branch. So for that locus, basically will based on the asymptotes angles. Okay, asymptotes angle. So we consider rule number 4 to find the asymptotes angle. So to find the asymptotes angle, we just will need to use the equation given, which is phi A equals to, in this equation from the textbook, we have 2k plus 1 n minus m. It depends. In some book, they use q. Okay, in some books, they use q. Okay, it's 2k plus 1 n minus m. N minus m is actually, let me just use the equation based on the lecture notes that's been given, which is phi A equals to 2q plus 1. I think I've given you this equation, 180 degree minus number of poles and number of zeros. Here q is 0, 1, 2, and so forth. So basically, let we substitute q equals to 0. So that phi A equals to 180 degree divided by P minus Z is 2. Okay, which is, this is 90 degree angle of the first angle. Let's find another angle. Q equals to 1. So phi A equals to 2q plus 1, which is 3 times 180 degree divided by 540. Divided by also 2. So 540 divided by 2 is 270 degree. Another angle. So we can continue q equals to 2, but end up we will get the same angle to 90 degree. It will repeat. So we'll just need to determine that two angles only. Okay, so since this one involves two locus, so we'll just need to find the asymptotes angle, two angles only. Okay, so to draw the straight lines, we will need that. Basically, to draw the straight line which asymptotes, we determine angle of 90 degree and another angle of, let's say, another angle here, start from horizontal. So this is 270 degree. Okay, so we have two angle that from there we can determine the straight line, which is asymptote. So that is what we're going to do later. So at this time, we just need to define the angle first, which is we get 90 degree and 270 degree. So we have done with rule number 4, finding the angle of the asymptotes. Okay, number 4 is angle of number 4 is angle of asymptotes. So once we find the angle of asymptotes, basically before we go to the rule number 5, because to determine the rule, the sketching based on the rule number 5 here, we will need to sketch first. All right. So basically, once we got the angle of asymptotes here, just directly find the centroid of the asymptotes. So I would like to go to rule number 6 first. Rule 6. So for the rule 6, to define the as a centroid, okay, or intersection, yeah, we will need to use the equation of sigma A goes to summation of real part of poles, so I just write it real part. You can also check your lecture notes, real part of poles minus summation of real part of zeros, okay, divided by number of poles minus number of zeros. That is the equation for rule number 6, which is to find the centroid, the centroid. Centroid or intersection. Okay, so how much is the real part of poles? Real part of poles 0 plus -4 plus -1 plus -1. Only real part, only real part. Let's have a check. 0, -4, -1, -1. Okay. Oh, but zeros, -2 and -3. And then minus summation of zeros, -2 plus -2. Okay. So that divided by P minus Z, which is 4 minus 2. So we have -6. -6. We have -6 plus 4 divided by 2, which is negative. Sorry, I just noticed that this is -2 and -3, right? Okay, so we have plus 5 lah. All right, 10. Okay, so from there we have -1/2, which is 0.5. So that is the intersection or centroid, -0.5. That is the intersection or centroid of the asymptotes. So basically, we can imagine that is the asymptotes. So this is the real lines, real axis, and then so that is -0.5, which is the centroid of the asymptotes, which is the point of the symmetrical. Okay, now we are going to draw so that we can have a check about the locus. Okay, so let me just start to draw sketch first. Okay, so we have all of the information given based on the rule number 2, 3, 4, and 6. So let we have a check by through our drawing. So we can just draw the axis first, which is this is j omega, the imaginary axis, and this is real axis. So we have how many poles? we have the pole location located at 0, 1, 2, 3. Let's say this is 1. So we have, okay, we have pole location at 0, -4, -1 plus j, -1 minus j. So we have the pole location at 0, 1, 2, 3, 4. So this is -4 location. Let me just move this to the right. Okay. So that I can continue it like that. So let's say this is -4. So we have another location of the poles at -4. Let's say I use white color here. This is -4, -3, -2, -1. All right. So I'm going to draw the poles at -4 and 0. So that is the pole at -4. And I have pole also at 0. And then I also have pole at -1 plus j. So somewhere around there. So this is okay, this is -1 plus j. This is j. This is minus j. So -1 plus j is supposed to be the pole location like right there. And -1 minus j, that is the pole location of the -1 minus j. Okay, how about zeros? Okay, let's check. How about zeros? So we have zeros, -2 and -3 on the real axis. So zeros at real axis, let me use another color for zeros. I think can just use the same color. So for zeros with different symbol, right? So at -2 and -3. So where is -2? Here. And -3 there. Okay. Now we have drawn all of the poles and zeros location on this S-plane. Okay. So you can have a check. So you can have a check. Now let's examine rule number 5. Let's examine rule number 5. All right. So for rule number 5, on the real axis, the locus only exists on the segment to the left of the odd counting number of poles and zero. The counting started at pole or zero located at the extreme right of the real axis. So basically, for the rule number 5, I've shown you also in the lecture. Okay, you can watch the lecture video on our discussion on root locus procedure. So, but basically for this case, let us examine where is the location of the locus on the real axis. The location of the locus on the real axis, basically, let me draw with green color. Let's pick up any point on real axis, okay? Let's say this point. So we have on the right hand side here, we have, is it odd number of poles and zeros or even number of poles and zeros? Yes, this time we have only one poles, okay? So it's odd number of poles and zeros, okay? So basically on that locus, any location in between these poles and zeros is valid. So meaning that locus is valid if on the right plane, okay, on the right segment here, we have odd number of poles and zeros, which is 1. 1 means odd lah. All right. So up to the 0, the next 0. How about this area? Okay, in between the -2 and -3. So we count how many poles and zeros. Okay, we have 1 pole, 2 pole. Oh, sorry, we have 1 0 and 1 pole on real axis. So we have 2. We count it, so end up in at 2, meaning that that is even. So if we got even number, then there is no locus between -2 and -3. All right. How about this location? So no locus, I do not draw anything between -2 and -3. So how about in between -3 and -4? Is there any locus exist in between this? Okay, we count the poles and zeros on the right hand side okay, of this location. Okay, so we have 1, 2, and 3, which is odd number of poles and zeros, meaning that locus exists in between -3 and -4 location. Okay, so we can just draw another locus. So clearly we have from rule number 1, sorry, not rule number 1, from the rule, basically, one pole will start and end at 0. Okay, one pole will start and end at 0. So we have this pair. So we have another pair of pole that will end at infinity based on the angle of asymptotes and also asymptotes, centroid and so on. Okay, so we will do it later, but for the time being, we should know that on real axis we should start from pole to 0, meaning that here we can just draw the direction of locus. Okay, direction of locus, which is start from pole to 0. Start from pole to 0. Okay, so we have just drawn the direction of the locus like that. So next thing we should do is to consider the root locus for these two complex poles. Okay, basically for these two complex poles, we know that it should start from here. Okay, start from that location and also that location symmetrically. All right. So here, since we already got our angle of asymptotes, and also we can draw the asymptotes first. All right. So in this case, let me just use the red color to draw the asymptotes, the lines, which is where is the location of centroid? Centroid is -0.5. So where is the -0.5? Basically, which is around here. That is the -0.5, right? That is -0.5, which is the centroid, right? That is the centroid. So basically, what I will do is to draw the asymptotes across the centroid. So how do we draw it? Basically, it is based on the angle of asymptotes, which is from horizontal lines. The first angle is 90 degree. The first angle is 90 degree, meaning that let me just draw with for you to see clearly. It shows this centroid, okay? So which is this angle, okay? That angle is 90 degree, okay? Another angle is 270 degree. 270 degree. So we have two angles here, 90 degree and 270 degree, which is the first 90 degree was there, all right? The second 70 degree is start from here, okay, and then it turns 70 degree. Where is it? So that is the location of the 270 degree, not 70, 270 degree, which is exactly what we see is the lines, the straight lines, which is the asymptote lines, asymptotes lah, which is the asymptotes of this case is, let me draw the asymptotes. I should go back so that I can remove all the red lines there. So I don't have the pembaris. Okay, I just draw it using my hand sketch here. So the line of the asymptote is right there. So that is the line of asymptotes, just next to the compact poles location. Okay, so that is the asymptotes. So I do not write anything on this to show you the angle of asymptotes. I hope you all know. Otherwise, it will be messy. Yeah. Okay. So we have drawn the asymptotes. Okay. Now moving on to rule number 5 is already done, which is the pole apa ni, the lines, the locus. We determine the locus. Okay, rule number 5, we determine the locus, which is that locus and the other locus between -4 and -4, sorry, between -4 and -3, also between -2 and 0. Okay, that is rule number 5. Now, we are going to focus on these two compact poles that it should have a locus as well. We call it as the departure angle. Okay, departure angle. So we should find the angle from any pole location. Let's pick up one pole location. Let's pick up this one. I'm going to pick up the pole, which is this one, to determine the angle, all of the angle, so that we can use rule number 9. Okay, for the rule number 9, you should have a check on your lecture notes that I've given to you in our earlier discussions, that we can determine the angle of departure. So we can determine the angle of departure using the equation. So we can find the angle of departure using the equation, but we are not going to use this equation. This is based on the textbook. So I have discussed with all of you before. You can use this equation, which is much more simpler. Okay, you can use that equation to determine the angle of departure. So you can find it in the lecture note that I have shared with all of you. All right. So rule number 9 now. Rule number 9. Okay. Angle of departure. So we can determine it by using this equation. Phi d, I'm going to use white color. Phi d equals to summation 180 degree minus sum of angle of poles minus summation of angle of zeros. All right. So let's have a check. Okay. So let's start from this one. Okay. I'm going to start from this pole. So you can choose any of the poles. Either this the bottom one or the top one. So I'm going to choose one this one, then to determine the angle of poles and angle of zeros with respect to the horizontal plane, with respect to the horizontal plane. So meaning that, okay, the first angle, let me show you using different color here. Hold on. The first angle is from -1 plus j location to the first pole at 0 location. So that is the first angle. Okay. So we know that this angle is 45 degree because this is -1 plus j. Okay. This location is -1 plus j. So it is half of 90 degree, right? So this particular angle, small one, that one is 45, and another angle here is 90 degree. So 90 degree plus 45 is 135. Okay, so the first angle with respect to the first pole here is 135 degree. Okay, so let me rewrite it. Okay, I'm going to go back. Otherwise, it will be messy. Okay. Okay, that is the first angle, which is 135 degree. Okay. So the second angle with respect to the horizontal plane, which is start from this pole to the bottom pole. Okay, to the bottom pole with respect to horizontal. Meaning that if I draw it, suppose that it will look like that. Okay, that is the second angle of the poles. Second angle of the poles. So another pole location is at -4. Suppose that the angle start from there. Oops. Angle start from there to the second pole location and to the horizontal like that. So that angle, how much is that angle? To determine that angle, actually we can use arc tangent lah. Arc tangent. Tangent -1 of here is 1, right? Plus j. Okay, meaning that this the vertical magnitude is 1. Okay, so this is 1, and from -4 to -1, it's 3, right? Okay, it's 3. That is 1. All right. So tangent 1/3. So we can find the angle. All right. So what is the angle of arc tangent 1/3? So I've done with my calculator. You can do it. You can have a check with your calculator as well. All right. So it's 18 degree. It's about 18 degree. Yeah? It's about 18 degree for that one. Okay. So I'm going to remove this to avoid messy. All right. It's already mess. What should I do? I just so this angle supposed to be 18 degree. 18 degree. So we have the first angle 135. This one is 90 degree and this one is 18 degree. So to find another angle at zeros, I'm going to use another color lah for that zeros. I don't have much more color. Let's pick up another one. Let's say that one. So start from again this pole. We draw this. Okay, for the first zero here to the horizontal. So that angle. Okay, that angle. That angle. To find that angle is we use tangent as well, which is tangent 1 divided by negative 2. 2 minus 1, what is the magnitude? Which is 1. Okay, 2 minus 1, that is 1 over there. That is 1. Okay, 1. So, pecek calculator. Okay. Arc tangent 1 is 45 degree lah. Okay. So, it's 45 degree. So, this one is 45 degree. So, the final one start from this pole to 0 here. Okay, another angle from that pole to 0 with respect to the horizontal, which is this angle. Okay, with 3 lines over there. So, I am showing that angle. So, what is that angle? We can determine using tangent negative. Okay, arc tangent 1 over 2, right? 3 minus 1 is 2. So, arc tangent 1 over 2. Just use your calculator. Tangent 1 over 2 is 0.5. Then we get the angle of 26.6. The angle of 26.6. So, this is 26 lebih kurang. Alright. So, we have all of those angles. Then we can determine, based on the equation here, we can determine the departure angle. Okay, so phi d is 180 degree minus summation of poles angle. So we have poles angle 135 and then 18 and then 90. So we have 135. We just use this 26.6 lah. Yang ni tadi. Ada hilang color dia. 26.6 lah. Okay. Alright. 180 degree. Poles ada 135, 135 degree plus 90 degree plus 18 satu lagi. Okay. So dalam equation tu we will need to minus. Okay, let me clearly put it as in the bracket. Minus summation of zeros punya angle. Zeros punya angle kita ada 45 dengan 26.6. Okay. So zeros punya angle we have 45 and 26. Sorry, 26.6. Okay, tutup. So from here we have 180 degree minus apa? So saya buat kurungan ya. Kirakan yang dalam ni lah. 135 tambah 90 tambah 18 tolak 45 tambah 26.6. So saya dapat dalam lebih kurang 171.4. 171.4. Okay, 180, 180 degree minus 171.4. We get 8.6 degree, is it? Right. So we have got the angle of departure at positive 8.6 degree for this particular pole. So departure angle 8.6 degree. So it was a bit messy for that one. I'm going to redraw it. Okay, let me redraw it. Right. Real axis, imaginary axis. So we have pole location right there, another pole location right there, and also we have the lines of asymptotes. Let me just draw pole location first. That is another pole location. 1, 2, 3, 4. This is -4. Another pole location. -4 here. -3, -2, -1. This is 0. Okay. And then we have the centroid around there, and the asymptotes. You can have a look that I am drawing the asymptotes, the straight lines there. So the locus, where's the location of the 0? At -2 and -3, right? So the locus start from, let's check. Yes, that's correct. So the locus on the real axis start from that one and also that one. So that is the two locus on the real axis. We have found the remaining two poles location at imaginary. So we have already determined the angle of departure. So angle of departure was 8.6 degree. Okay, where is 8.6 degree? Somewhere around there. For this is 8.6 degree. All right, from horizontal. And for the symmetrical, for the other one, suppose that it should start 8.6 degree from horizontal. Let's say this is the horizontal. Suppose that it is -8.6 degree because it is symmetrical. So I've just sketching like that because I'm going to show you the angle, which is 8.6 degree angle is like that. Right? Then I'm going to, I will just remove that so that I can draw the locus. Now it is the time for me to draw the locus at 8.6 degree angle from horizontal for the positive imaginary axis pole here. So the locus should start from here. So locus should start from here and at angle, alamak, saya nak buat ni lines macam tu bagi nampak. So it should start at angle 8.6. That angle is 8.6 degree. Angle of departure. Nampak tak? Okay. And another angle of departure with respect to horizontal, that is -8.6. -8.6 angle of departure. So we know that this locus, the top locus, the locus of the top poles to 0. It's not going to zeros, but to the infinity. Okay? To the infinity based on this line, which this line, this is the asymptotes, so that we can just draw it something like that toward the infinity. Macam tu. Okay. For the bottom one also, we should start from there at angle of departure of 8.6 moving to negative infinity. So that is the root locus, root locus of this particular system. So for the last one, we have remaining two poles that will end up to infinity. But although we already know that these two poles will end at infinity for the locus, but basically we'll need to define the angle of departure. Okay. Kalau you tak calculate angle of departure ni, just lukis je macam tu, tak ada markah lah untuk angle of departure. So basically you will need to show the angle of departure and draw the locus like this. So once the locus approaching the asymptotes, it will moving toward whether it's positive infinity or negative infinity lah. Alright, so it should look like this. And then at this instant, it will not going to touch the lines of asymptote, the asymptote, but just moving toward the infinity. So this is the root locus that we want to draw based on the equation here. Okay. So I hope that from this example, it's already cover a lot of things based on the procedure that we have learned. So we have 10 rules here. So basically, so you can have a try for different questions. You can have a try based on the different question to draw your own root locus, okay, based on these rules, right? So keep practicing so that you get you get familiar with it, and then okay, that's all for the tutorial. So it's 45 minutes. Okay, thank you. Assalamualaikum.